Hello, my name is Peter Schlenker, and my project's about generating point clouds from photos. So, for the motivation for my project, a 3D artist will often scan models from the real world using a process called photogrammetry, where you take lots of photos of an object from lots of different angles, and then you use software to piece together a 3D model. So, a software that is commonly used for this is called Reality Scan. And the way that software works is it first takes in all the images and aligns them, and then it generates a point cloud from those aligned images, and then finally it reconstructs a mesh from the point cloud. So for my project, I want to recreate part of that workflow, specifically the part about taking aligned images and then generating a point cloud. So this is a point cloud generated using a different software called CallMap. So the algorithm that I use to do this is as follows. You take the image stack, and then for each iteration, you randomly choose one of those images, and then randomly choose a pixel inside that image, and also a template, which is the area surrounding that pixel. And if the template does not have enough contrast inside it, then you choose a different pixel that has a template with better contrast. Then for that pixel, you calculate the ray into the scene using the camera position. And then you go through all the images, that are the other images in the stack, and the images that are nearby, so looking at the similar area, taken from like a similar location. You calculate the epipole and epipolar direction from the ray of the first image. If that epipolar line does not intersect the image we're considering, then we don't consider this image, because the intersection point is not in it. Then we look at every pixel along that epipolar line and match it with the template from before. And then we find whichever pixel matches best and use that to calculate the depth relative to the first image. Then after we do that several times, we'll have several depths, and then we can average those depths to get a more accurate estimate of the depth at the pixel in the first image. And then we can use that original ray to calculate a 3D point in the scene and assign it the color of the first image. So the inputs I used for this algorithm are the image stack of 103 images. I put this crochet dragon on a table and took pictures from all directions. And then for the input data, the aligned images, I used CallMap. So each of these red is the images that have been aligned. If I were implementing like the full workflow in Reality Capture, I would implement this step too, but I'm just focusing on that second step of taking the aligned images and generating the point cloud. But unfortunately, I was unable to get it to generate a good result in the time we had for this project. So I'm not sure if it's because I have a bug in my code somewhere that I haven't been able to find, or maybe the template matching that I've been using is not robust enough. Because the way I've been finding the best match is just by a distance metric. So compare the template to the patch, you subtract it to get, and then square that and sum it to get the distance. And then like the smallest distance is best match. So I'm not sure if that metric is not robust enough and it's getting finding incorrect matches, or maybe it's something else. Also, the final point cloud I exported, I'm not sure why it's not showing the colors here, but it does assign colors in the code. But in theory, this algorithm should give a better result than 2-view stereo because it's not just two images, it uses lots of different pairs of images to estimate the depth. And then I'll also show, here's the model again, just from different viewing angles, the reconstruction. And then this is what CallMap reconstructed. So the goal of this project was to get a point cloud like this, although I was unable to get a result quite like this.